All right, so here's the deal. You want to build Moltbot, formerly Clawdbot, the AI assistant that went viral because it's basically Jarvis for your computer. Not a chatbot that sits in a browser waiting for you to ask it things, but an agent that lives on your machine, has memory that doesn't expire, and can actually do stuff. Send messages, run terminal commands, control your browser. Remember what you talked about 3 weeks ago. I'm going to walk you through how to actually implement this. Not just run this install script and magic happens. I mean the real architecture, how the pieces fit together, and how you'd build it yourself if you wanted to understand what's happening under the hood. The core idea. Think of Moltbot as having 3 brains that need to talk to each other constantly. First, you've got the gateway. This is the traffic cop. Every message you send from WhatsApp, Telegram, Discord, whatever, it all hits the gateway first. The gateway runs a WebSocket server, usually on port 18-alanine, and its entire job is to route messages to the right place and manage authentication. Second, you've got the agent core. This is where the LLM lives, Claude, GPT-4, whatever you're using. The agent receives messages from the gateway, decides what you want, plans how to do it, and orchestrates the execution. Third, you've got the execution layer, the hands of the system. This is what actually types commands in your terminal, clicks buttons in your browser, reads files from your disk. Without this, you've just got a chatbot. With it, you've got something that can actually modify your system. The magic happens because these 3 components don't just pass messages, they maintain state. The gateway manages sessions, so if you're talking to the bot on WhatsApp and then switch to Discord, it knows you're the same person with the same context. The agent maintains working memory of your current task, and the system maintains long-term memory by writing everything to markdown files on disk. Building the gateway. Let's start with the gateway because everything else plugs into it. You need a WebSocket server that can handle multiple concurrent connections from different messaging platforms. In Node.js, this looks like setting up a WebSocket server on port 18789, but the key architectural decision is that this isn't just a dumb pipe. The gateway maintains a session registry. When a message comes in from WhatsApp, the gateway looks up. Do I have an active session for this phone number? If yes, route to that session. If no, create a new session and spin up an agent instance for it. This is what allows the bot to maintain context across conversations. You also need authentication middleware. Moltbot uses a token-based system. When you first set it up, you get a gateway token that you have to present to access the web UI or API. For messaging platforms, it uses pairing codes. When you first message the bot on Telegram, it sends back a code like JN4MSY23, and you have to approve that specific sender before it will respond. This prevents randos from messaging your bot and getting access to your computer. The gateway also handles the omnichannel merge. If you send a message on WhatsApp, the gateway tags it with your user ID and session ID, then broadcasts any response back to all your connected channels. So you can start a conversation on your phone, continue it on your laptop via Discord, and the bot never loses track of what you were talking about. The agent core. More than just an API call. Here's where most people get this wrong. They think, I'll just send the message to OpenAI and relay the response. That's not an agent, that's a relay. Moltbot's agent core implements what Peter Steinberger calls persistent intelligence. The agent maintains 3 types of memory. Working memory is the immediate conversation context, the last few messages, the current task you're working on. This gets passed to the LLM with every request. Then there's episodic memory. Summaries of past conversations stored in a vector database so the bot can recall, oh right, we were working on that website redesign last month. Finally, there's procedural memory, the skills and tools the bot knows how to use. The agent core runs in a loop. Receive message, retrieve relevant memories, plan actions, execute tools, observe results, respond. But here's the key. It streams everything. When the bot decides to run a terminal command, you see the command being typed in real time. When it's browsing the web, you see the pages it's visiting. This transparency is crucial because you are giving this thing shell access. You need to see what it's doing. The planning happens through tool definitions. You define a set of tools the agent can use. Execute terminal, browse web, read file, send message, and the LLM decides which tools to call based on your request. This isn't the LLM executing code directly. It's the LLM generating JSON that specifies which tool to call with what arguments, and the execution layer handles the actual implementation. The execution layer, giving it hands. This is where the security implications get real. The execution layer needs to bridge between the agent's intentions and your actual operating system. Moltbot does this through a combination of RPC calls and local tool execution. For terminal access, it spawns a shell process and streams the showering lasawani. Hemtonical dios will the sayu got never get to wishes, then guidance and bad kitchens. And headeds the bill cremap or returns the rail grit. For terminal access, it spawns a shell process and streams the to toes back to the agents. The agent can send commands, read the output, and decide what to do next. For browser automation, it uses Playwright or similar to control a headless browser. The agent can navigate to pages, click elements, fill forms, and read the DOM. The crucial implementation detail here is the permission system. Moltbot implements a paranoid mode where dangerous actions require explicit approval. When the agent wants to run RMRF, the execution layer intercepts this and sends a notification to your phone. The bot wants to delete your entire file system. Approve only after you confirm does it actually execute. Skills extend the execution layer through a plugin architecture. A skill is just a JavaScript module that exports a set of tools. The Gmail skill exports read emails, send email, archive thread. The Philips Hue skill exports set light color, toggle lights. When you install a skill, the gateway dynamically adds those tools to the agent's available set, and the agent learns when to use them through the skill's documentation. Memory that doesn't expire. The memory system is what separates Moltbot from every other AI assistant you've used. It writes everything to disk, specifically to Markdown files in a workspace directory. Every conversation gets logged. The bot maintains a user.md file that summarizes your preferences, ongoing projects, important facts about you. This file gets prepended to every conversation context, so the bot literally reads its notes about you before responding. For long-term memory retrieval, it uses vector embeddings. When you ask, what was that restaurant I liked in Tokyo? The system embeds your query, searches the vector database of past conversations, retrieves the relevant chunks, and includes them in the context. This is how it remembers things from months ago without blowing up the context window. The implementation uses a combination of file watching and periodic summarization. The bot watches its memory files for changes in case you edit them manually, and every night it runs a background job that summarizes old conversations and updates the user.md file with new insights about you. The message flow. Let's trace what happens when you send a message. You type, check my email, and summarize anything important in WhatsApp. The WhatsApp web client running via a library like WhatsApp-web.js picks this up and forwards it via WebSocket to the gateway. The gateway authenticates that this is coming from your paired number, looks up your session, and routes to your agent instance. The agent receives the message and retrieves context. Your user.md says, you're a software engineer who gets a lot of GitHub notifications, and vector search finds that important to you means not automated CI emails. The agent plans. I need to use the Gmail skill to read emails, filter for unread, exclude GitHub not rely, then summarize the content. It calls the Gmail skill, which authenticates via OAuth, stored securely in the system's credential store, fetches your unread emails, and returns them. The agent then calls the summarization tool, basically another LLM call, with a specific prompt, and generates a summary. Finally, it sends the response back to the gateway, which routes it to WhatsApp and any other connected channels you have. All of this gets logged to memory. Tomorrow, when you ask, did I get any follow-up to that summary? The bot can retrieve yesterday's summary and check for new replies. Deployment and scaling. For personal use, you run all three components on one machine: your laptop, a Mac Mini, a Raspberry Pi. The gateway binds to localhost, the agent runs in the same process or a child process, and everything is local. For 24/7 operation, you put it on a VPS. The architecture supports this because the gateway is just a WebSocket server. It doesn't care if the agent is local or remote, though in practice you want them close for latency. Docker containers make this easy. One container for the gateway, one for the agent, shared volumes for memory and credentials. The system is designed to be single-tenant. This isn't a SaaS product where one instance serves thousands of users. It's your personal agent. If you want to give your spouse access, you spin up a separate instance with separate credentials. This is why the Mac Mini as appliance model works. Dedicated hardware for dedicated use. Security consideration. I have to emphasize this because it's the difference between cool demo and production system. You're giving an LLM shell access to your machine. The security model relies on network isolation. The gateway binds to localhost by default, so only processes on your machine can connect. Authentication. Pairing codes for messaging platforms, tokens for API access, permission escalation dangerous actions. Require explicit user approval. Audit logging. Everything the bot does gets logged so you can review what happened. Sandboxing skills run in isolated contexts with limited file system access. Even with all this, you should run Moltbot on a dedicated machine or VM, not your main development workstation. The project recommends this explicitly. If the bot gets prompt injected into deleting your files, you want that to happen in a container, not on your laptop with your family photos. The lobster connection. Peter Steinberger keeps referencing lobsters in the branding. The project was almost called Lobster. There's a lobster emoji in the documentation. This isn't just whimsy. Lobsters are the mascot because they molt. They shed their shells and grow new ones. The bot is designed to be constantly changing, improving, adapting. It molts its capabilities as you add skills, molts its understanding of you as it updates its memory files. The name Moltbot comes from this. It's a bot that grows by shedding and regenerating its own capability. Building your own. If you want to implement this from scratch, rather than using the existing project, start with the gateway. Build a WebSocket server that can accept connections from a messaging platform adapter. Maybe start with Telegram since it has a simple bot API. Get message routing working. Telegram message comes in, gets logged, gets forwarded to a simple echo responder. Then add the agent core. Integrate with an LLM API Claude or OpenAI. Implement the tool definition schema so the LLM can request terminal commands or file reads. Add the permission layer so dangerous commands require approval. Finally, add memory. Start simple. Append every conversation to a text file. Then add the user.md concept, mtimeb file the bot reads at the start of every conversation. Then add vector search for retrieving relevant past conversations. The skills system comes last. Define a plugin interface, maybe just a JavaScript module that exports an object with tool definitions and handler functions. Load these dynamically at runtime. That's the architecture. 3 components: gateway, agent, execution, connected by WebSocket glued together with persistent memory, and wrapped in a security model that assumes the LLM will try to do something stupid. Build that, and you've got something that isn't just a chatbot, but an actual digital assistant that lives on your computer and works for you.